Ladies and gentlemen, esteemed guests, colleagues, and fellow space geeks, it is my distinct pleasure to introduce a true luminary in the field of aerospace engineering and space exploration. Today, we're joined by none other than Wayne Hale, a man whose career at NASA has not only shaped the trajectory of American spaceflight, but also inspired countless individuals to look up at the stars and dream of the possibilities. Wayne began his illustrious journey at NASA as an engineer, quickly proving himself to be a leader, a visionary, and a pivotal figure in the Space Shuttle Program. Under his guidance as the program manager, the shuttle not only carried astronauts and satellites to orbit, but also embodied the spirit of human curiosity and our relentless pursuit of knowledge. Following this, his tenure with the Space Shuttle, Wayne continued to impact the field through his role on the NASA Advisory Council, where he provided expert advice on various initiatives, ensuring that the torch of innovation and exploration continued to burn bright. Wayne's contribution to space exploration have been recognized with numerous awards and honors, yet it is his unwavering commitment to advancing human spaceflight that truly sets him apart. His insights have illuminated the path for future missions, and his leadership has helped navigate the complex challenges of putting humans in space. It is my pleasure to invite Wayne Hale to be our speaker today. Wayne, it is your floor.
Thank you, Svetlana. I'm blown away by that really wonderful introduction. I didn't provide that to her. She wrote that all on her own. I just wanted to add a couple of little thoughts to that. In addition, to spending most of my career working the Space Shuttle Program, and I see several friends here that worked with me in those days, and in flight operations and then in the program office. I got asked to join the NASA headquarters team in 2008 and was, among other things, assigned to assist the Augustine Commission. You may remember that study, that blue ribbon panel that reviewed what was at that time the Constellation Program. And it was a very enlightening and educational experience for me to watch that group and how their report got used and the results from that. As you recall, they recommended that the Constellation Program to go back to the moon was unsustainable, which was a word that I had not heard used before. So I've spent a lot of time studying that. And they also recommended that commercial space should be brought to the forefront. And after that commission report came out, my boss, Bill Gerstenmaier at the time, asked me to work on a team to define how NASA would incorporate using commercial space providers in future programs. And out of that became the Commercial Crew Program Office. After I retired from NASA in 2010, I went to work for a small engineering consulting firm and spent the last 13 years providing advice in the private sector to various commercial organizations and a little bit back to the government. But it was very concerned with this commercialization aspect of human spaceflight, and I've got to say it holds great promise. So in the middle of that, Charlie Bolden asked me to join the NASA Advisory Council, and I spent about 10 years on the NASA Advisory Council, which is basically a volunteer group of senior folks that provide advice to the NASA administrator. We got a large number of briefings. We got hardware tours. We heard a lot of really interesting presentations on not just what was being planned, but the rationale behind that. And then they asked our opinion of it, which we provided on a regular basis. But coming up in the end of last calendar year, 2023, I decided it was time to hand the reins over to a younger generation. I've been doing that for 10 years. And also to step away from the consulting role. So as of January 1st, I'm completely retired. And you can see me at all kinds of NASA Alumni League or other retiree events, and I want to become more active in the AIAA Houston section, for example. So that's a little bit of my background, and I thought because there is always a lot of interest in the Artemis program and how it works and why they're doing things the way they're doing it, I might give a little bit of perspective since I had quite a lot of time to think about this and got quite a lot of information. In this community, of course, we are all very interested in space exploration, particularly in the Houston section and human space exploration. Not to give a short shrift to the robotics folks or any of the other science work or the other parts of NASA like aviation, but we're very interested in human space flight. Then I come from a generation, I was born before Sputnik, that tells you how old I am, that really grew up with space exploration as a factor in our lives and committed to the idea that human exploration of outer space is really important and something that this nation needs to pursue. So given that as a basis, of course, we all watched Apollo. There might be a couple of folks on here that actually participated in the Apollo program, and that was kind of the seminal event for many of us that solidified the idea that we need to continue on in space. And so we come to the Artemis program, which is ostensibly going to do that. But it is one design point, if you want to think about it. There's many ways to achieve those goals, and this community is really engaged in a debate frequently about how best to achieve the goals of sending people back to the moon, onto Mars, and to other places in the solar system, and then maybe someday beyond that. But pardon me, I think it would be good to bring a little background and maybe give you my perspective, having studied on this pretty closely for a long time. And I don't think there's anything surprising, and I really don't want to see this written up, in the in one of the space publications, but I'm sure it might be because it's not entirely supportive of what's going on. But on the other hand, it is a program that's going forward. So for just a second, step back to Apollo. You all remember Apollo was set up by John Kennedy, and the president, of course, was desperate to do some great thing. The United States needed to do some great achievement that would demonstrate to the world the superiority of the United States, democracy, and the free enterprise system over Soviet Union, communism, totalitarianism, planned economy, if you want to think about it that way. And so he was advised that the space program was a way to do that, and the goal of landing Americans on the moon within a decade was something that would electrify the world, and in fact it did. Many of us, I think, growing up in those days, didn't quite understand that he really wasn't interested in space exploration per se. He was interested in beating the Russians, and that kind of caused a whole series of events to transpire. But Apollo really was a huge demonstration, but it was all about winning a space race with the Soviet Union. And so after Apollo was over, Most Americans, much to my chagrin, said, okay, well, we've been there, done that, let's go spend money on other things. And so Apollo program ended after 6 landings, and any plans to go on to Mars or do other things, of which there were many options, were killed by the government, by the presidential administration, but don't think it was just a decision of the president. That really, going back and looking at it, reflected the spirit of the times. People were interested in other things. And so if you're going to use the government, if you're going to use taxpayer money to fund your space program, you have to have political support, and there wasn't any very much. And we wound up with the shuttle, which is a whole series into itself. But the fact of the matter is Apollo ended. It was, in Augustine terms, unsustainable, not necessarily unsustainable from the money standpoint, although it was quite expensive in those days, but unsustainable from the political standpoint. And then we've been waiting 50 years. Those of us that are interested in humans exploring space, we've been waiting more than 50 years to send people back to the moon. And that's what Artemis is set out to do. One of the things that I think is very important for those of us that are looking at the follow-on space program and continuing into space is that this is not a repeat of Apollo. This is not flags and footprints. The goal is to go in a sustainable way where we can live and stay and set up a space economy that will be, self-funding to some degree, but also then enable transportation onto Mars. And I think the debate about moon first versus Mars first, which went on for a number of years, has been decided in terms of moon first, which makes a lot of sense to me, learning how you operate in space closer to home before you set out on the really long and much more difficult prospect of going to Mars, being the next logical place to go in the solar system. But we have all, I think, basically come to the conclusion that moon first and then Mars and then other places, I hope. But if you go back to Apollo, early on in Apollo, they made some design decisions which I think were very interesting and influenced the way that Apollo played out and are different than what we're doing or what is proposed to be due for Artemis. But remember the goal for Artemis, not just go back and maybe beat the Chinese this time, although that may be desirable, but go back in a sustainable way that has multiple missions and continues on into the future and isn't just a one-shot flags and footprints. And if we're not careful, the politicians who love to have this space race mentality will glom onto the competition, and they'll fund Artemis through the first lunar landing or maybe a couple, but then interest will wane and the money will go away. So we need to always emphasize this is a sustained long duration program, and in my mind, while it would be very nice to beat the Chinese, who apparently are our main competitors these days, that's not the primary mission. The primary mission is to go back in a sustainable way. So Apollo, as you'll recall, in the early 60s, if you studied on that, did not know how to achieve a lunar landing. And all the early studies were for what we call direct descent, where they built a really huge rocket that had everything all packaged together, and everything, the what we would call command module, service module, lunar module, or lunar lander, all landed together. And then the command and service module took off from the surface of the moon in a direct return to Earth. So they designed the Apollo service module with this really large propulsion capability. The service propulsion system engine could lift the whole spacecraft command and service module off the surface of the moon and had enough delta V capability to send it all directly back to Earth. But as they worked on this design, they realized that the Saturn V rocket, or what became the Saturn V rocket, it didn't have the lift capability to carry that huge spacecraft. And they had plans to develop an even larger rocket called the Nova rocket. But that was going to not be possible in the time frame the president had given them of doing that within 10 years. So they started exploring other options, Earth orbit rendezvous and lunar orbit rendezvous, and of course, lunar orbit rendezvous won that discussion, but they had already let the contract for the command and service module design and build before they made that decision. So we were left in Apollo with this very propulsion capable service module, much larger than was really needed. And that's where we were in Apollo. One of the things that they did in Apollo was they could use that large propulsion capability to insert into a really low lunar orbit, 80 or so nautical miles off the surface. And that's important because that's not the way it's being done today. So we're going to fast forward a little bit to the future. And those of us that lived through the cancellation of the Constellation program and the floundering for several years remember some of these decisions. The Constellation program proposed a huge lunar lander called the Altair lunar lander, and it required a number of launches of their big rocket called the Ares 5 to carry out a lunar mission. So the crew would go up on what we now know as Orion, what they called the multipurpose crew vehicle, MPCV. Now it's Orion with its little service module, and it would meet the Altair in Earth orbit, and the Altair would provide the translunar insertion burn, as well as the insertion into lunar orbit, and then ferry some of the crew down to the surface and back up to the Orion in lunar orbit, who had a very small propulsion capability that was only really needed to provide the trans-Earth injection to get it back on a trajectory to the Earth. So it had a very small service module propulsive capability compared with the SPS. Over time, it became interesting that the prospect of having ice water at the lunar poles, particularly the South Pole, became an objective, because if you got ice, and we've all been through this, you can make water from it, you can make oxygen. If you disassociate the materials, you can make rocket fuel, hydrogen and oxygen. So effectively, you've got a resource to live off the land. You don't have to carry the whole mass to and from the moon. So it's very advantageous to take advantage of the resources at the moon, particularly that lunar ice, which, by the way, we don't really know is there. We've got some, orbit sensing indications that it's probably there, but exactly how much and how hard it's going to be get out of the regolith, so forth, is still ahead of us. And that's why they're sending this Viper robotic spacecraft to the South Pole of the moon in another year or two to really get some ground truth to see how much there is really there. But there's a little bit of a race going to the South Pole. But as this evolved in the political world, when Constellation got canceled, elements in the United States Congress did not like that, assisted by a lot of industry lobbying, and they were able to keep the MPCV in its form, the Orion spacecraft, as it had been basically designed. And then the Ares 5 large launch vehicle was canned, but Congress mandated that they build a large rocket based on shuttle technology, which has become the SLS, the Space Launch System, which really needs a good name, but doesn't have it. So now you've got a large launch vehicle that can carry the Orion on its way to the moon, but you've got an Orion that's got very little propulsive capability and does not have enough propulsive capability to get into low lunar orbit. It can't do it. Plus, well, I say get into, it could get in, but it can't get in and out. Let's just say that. So it's got to attain a high lunar orbit, which is less delta V intensive. And we don't have a lunar lander. So if you'll recall Apollo, the Grumman lunar module, actually was the long pole in the tent development. It was harder to develop than anything else, took longer, and really paced the whole Apollo program to get that lunar lander developed. NASA, because of budgetary constraints, actually didn't start pursuing the design and development of a lunar lander until not much more recently, much later than anything else. And therefore, it stands to reason that the lunar lander will pace the program, and we'll be waiting on the lunar lander, which I'll come back to in a minute, for a long time. So we're faced with a couple of things. We have a crew capsule that can't get in and out of low lunar orbit because it doesn't have a delta V capability. And we have to send the lunar lander on a different rocket. It's got to be a 2-launch as opposed to Apollo. So we need a place to rendezvous with that lander somewhere, Earth orbit, lunar orbit, somewhere, so we can meet the crew and get them down to the lunar surface and back. And I've got a little video. Let's see if I can share this. So they came up with this thing called, can you see that? Somebody tell me you can
Yes,
see
it's
it,
showing.
Jason.
It's playing.
So you can see the near rectilinear halo orbit, and I'm going to try to go full screen on that. I can't do it. See, just a second. Yeah, you don't want to see me. Well, in any event, let me run it again. And in the upper right corner is the view from the Earth. And one of the neat things about this orbit is it comes down over the South Pole. This is seen from the Earth, and you have continuous communication to the Earth from the spacecraft from that orbit. But it allows for an orbit where you can put a small way station, a rally point, a rendezvous point, that the crew module, the Orion, can meet the lunar module, whatever name we apply to it, and transfer crew. And some of the crew can stay there, some of the crew can come down, but it provides a low delta V solution to get in and out of lunar orbit, which is what's required with our current iteration of Orion. By the way, I used to have a long discussion with the Orion program manager about building a larger service module, a more propulsive capable service module, and for budgetary and schedule reasons, that was just impractical. Anything's possible given enough time and money, but given the budgetary constraints on Artemis, building a bigger service module just wasn't in the plan. And of course, there's other political considerations. The service module is being built by the Europeans as their contribution, and we frankly want to keep them, involved. So there's several reasons to stick with the existing service module that have trumped perhaps the desire to have a more Apollo-like vehicle. So we're stuck with having to insert and return from a high lunar orbit. We also want to go to the South Pole or the North Pole, but principally the South Pole. And so that's what we're looking at. And frequently people ask me, well, why in your rectilinear halo orbit? They studied all kinds of orbits. This provided the best in terms of comm and thermal and propulsive delta V. The bad news for this orbit is once you land on the moon, you've got to wait 6.5 days for the orbit to come back around so you can get off the moon. So your abort options or early return options are limited if you need to get off the surface and back. You've got to wait for a while to make that, which is not unlike perhaps what will be the story at Mars someday, except it's a much longer wait there. So given what we've got, they built the big rocket, the SLS has flown, the Orion has flown. It's been demonstrated. We're going to put crew on the Orion next time and actually send it on it's not really Apollo 8 type mission. It's not going to orbit the moon. It's going to fly by and go beyond the moon. I'm sure we'll see lots of really great pictures, which is neat. But it will be at least Artemis 3 before we actually send crew into lunar orbit. And that's what I wanted to say about the near rectilinear halo orbit. I hope that little video helped. So we're faced now with the problem of building a lunar module, and NASA, because of the success for the commercial cargo resupply of the space station and the success of the commercial crew program, has elected to follow that model to develop lunar landers. And they had a competition. There were three entities that competed for the lunar lander. SpaceX won that competition. Dynetics, who I thought had a really innovative and great design, lost, as well as Blue Origin. They, in NASA's wisdom and given enough money by Congress, a couple of years later, NASA decided they needed to have a second source for lunar landing services, and picked Blue Origin. So today we've got a SpaceX with the contract to provide the early mission lunar landers with their Starship, and Blue Origin with a follow-on lunar lander to actually, maybe compete. So that makes both teams work harder. And the models are not terribly different. Both organizations are building large new launch vehicles, and they have to provide an on-orbit refueling capability to carry oxygen methane to their on-orbit landing vehicle, which gets tanked up over a series of tanker flights and Earth orbit, and then goes out to the waypoint, which we're calling Gateway, in lunar orbit to meet the crew, and then that does its mission, comes back, and is ostensibly reusable, but has to be refueled. And we're into a cycle of needing a number of very large launch vehicle launches to provide the propellant to be taken up to low Earth orbit to fill up the tanker to refuel the lunar lander. Now, refueling, propellant transfer, in particular cryogenic propellant transfer in space, has been a staple of all the long duration advanced program studies for space exploration for years, decades, and developing that technology will be a great benefit to going forward. But it is a new technology is being developed. Cryogenic propellant transfer between two vehicles in outer space has never been accomplished to date. There's been a lot of groundwork. There have been a couple of studies on orbit where, with tanks that are already connected, they pump back and forth. But, cryogenic propellant transfer is probably the biggest technological problem to be overcome in the Artemis program, and it has yet to be demonstrated. And then there are going to be a large number of these very heavy lift rockets, either the Starship or the New Glenn, to carry propellant up for each mission. So the logistics are very difficult. If you were going to go quickly and just try to beat the Chinese, several people, including my old boss, Mike Griffin, have proposed building a much simpler, non-refueled lunar lander, and certainly that would get you there quicker. But hey, we've already got these designs in development. The Starship has already flown a couple of test flights. The Blue Origin vehicle is well into design. So, changing horses at this point would only delay things, in my opinion. So we have a program that is going to be very expensive. Let's just face that. The SLS, built in the traditional way, is an inordinately expensive launch vehicle, something on the order of what Saturn V's cost. And so there is a real need to figure out ways to build a launch vehicle that's more economical. Certainly, that's what Blue Origin and SpaceX are trying to do, build launch vehicles that are much more economical. And in fact, SpaceX has had great success with their Falcon 9 rocket, building a much more affordable launch vehicle in that size range. To build these larger vehicles that will be reusable and we hope will be more economical is going to be is very difficult. And we've all seen the work going forward on those. So the question ahead of us, I think, is at some point, if SpaceX or Blue Origin are successful in building these lower cost heavy launch vehicles, do we need an SLS? Let me warn you, don't ask that question in North Alabama because it's heresy. But that is something that's going to have to be faced in the future, is that if we have these other launch vehicles that are as capable as the SLS, and they are demonstrated to be as reliable and are much more economical, why would we continue to build SLSs? But that's a question for the future, because neither of those launch vehicles have demonstrated high reliability, nor have they really demonstrated any economy at this point in their test program. But if we are to have a sustainable, and I want to go back to that Augustinian word, a sustainable space program going forward, it's got to be less expensive. I mean, that's the number one thing. Well, maybe the number two thing. The number one thing is it needs to fly and fly frequently, which kind of runs in the face of economy. But we have a program. It is a point solution right now that does fulfill the basic requirement of returning to the moon, developing technologies to go on to Mars, and building the potential for a sustained lunar presence. So right now, that's a point solution that works. As engineers, we have to watch our tendency, and I know I'm just like every other engineer, is you can always think of a better way to do it, but you have to throw away what you've done and start over, and the cost and schedule associated with that become prohibitive. And getting permission to do the thing in the first place is a difficulty in the political world. At some point, and perhaps this is the advantage of using the commercial vehicles, at some point, would we be able to get away from government funding? I know those of us that worked in NASA forever, that's a little bit of a new thought. But if there are commercial capabilities and industry can carry part of the burden or provide part of the capability and alleviate the cost to taxpayers, that makes the program much more sustainable. So we got that, and I am just about out of thoughts. So my summary, if you will, on all of this is we have a program. It has the potential to work. Yes, it will be more expensive than projected. Yes, it will take longer than projected. It already has. Everything in aerospace seems to be that way. But yes, it will work. And tearing it up and throwing it away and starting over with a better design is really a non-starter from the political, financial, technical standpoint. Even though as engineers, we can always dream of better ways to do things. And one of the really interesting things about Artemis is that it's going to demonstrate some critical capabilities that we need for the future, and cryogenic propellant transfer in space is one of them. So pros and cons. Am I in favor of Artemis as designed? Yes, gung-ho, let's get after it. Let's fly sooner. However, we really have to make it more affordable. We really have to fly more often. And by golly, our commercial partners have to perform. So I'm going to stop right there. I'm seeing there's some questions in the chat. I don't know. Let me answer a couple of those. Let's see. Can Orion be launched on any other launch vehicle? Falcon, well, it could be launched, but it can't be launched with the capability to and the trajectory to get into outside of low Earth orbit. So yeah, the EFT-1 mission flew the Orion on a Delta IV Heavy, which, by the way, just retired. There are no more Delta IV Heavies. It's gone, but that didn't have the capability of going to the moon. There wasn't enough Delta V capability. You need a bigger rocket. After the initial Artemis missions, do you think the transition from exploring to establishing surface outposts should start? Yes, I do. Absolutely. I think that's part of it, and people are working on those plans. We have. I just talked. I was at a retiree event last night, and I got to talk to a couple of folks that are involved still with the agency in doing that, and I think that's in the plan. And I really think that's vital for the long-term future. But again, remember, we are talking to ourselves. We're the space community. We are dedicated to getting humans into space, going to the moon and other places. The rest of the nation, kind of maybe not so much. Okay, now we got another question. What? And so it's not just a question of technology, it's a question of the political will of the nation. With cryogenic fluid transfer demonstrated, what do you envision as the future of human space exploration? Well, I think there's a couple of things. I think the other big technology that's got to be demonstrated is nuclear propulsion, because we've got to become more efficient in the use of propellant, and we've got to have faster transit times, particularly to Mars. And so, the next thing I'd invest in after we, and we're so early in the development of cryogenic fluid transfer that I hate to put it this way, but once we crack that nut and understand how to do that with all the couplings and chill downs and losses and pump issues, and it looks really good in an academic paper, but the practical matters have to be solved. Once we get that solved, I think nuclear propulsion is our next. And I see Jim Ryder out there. Jim and I talked about this a lot when we was head of STMD, and there is a demonstration project between NASA and DARPA for a nuclear thermal propulsion demonstration in a few years, which I greatly applaud. But I think those are the two technologies that really have to be developed. And I'm not putting down anything. I mean, spacesuits, transportation on the moon, how to handle moon dust. I mean, there's more challenges out there than you can shake a stick at. So I'm going to quit. And Svetlana, do you want to open it up to questions or discussions? How do we do this?
Yes, essentially everyone is welcome to unmute. You can also turn on your video. And in order to have it more organized, or at least civilized, I guess, if you can raise your hand and then we can see who's first, so we don't talk over each other. But feel free to raise your hand, feel free to ask a question, and continue and support the discussion. I have a few questions that came earlier, and I wanted to ask, perhaps it will lead into maybe a slightly different direction, but what is your opinion on the Artemis being a precursor to a Mars exploration? And the second question is, if the Artemis program just focusing on lunar exploration, would that be essentially putting Mars program out of sight.
So it's my opinion, after having, worked in space operations for most of my career, that you've got to walk before you run. You've got to do things, learn how to do things. And while I think we're all very interested in humans to Mars, and I think that is what's the term they like to use, a horizon goal. Okay. I think going to the moon first is really required. And if you really try to go straight to Mars, as maybe Bob Zubrin would advocate, you're going to run into a lot of difficulties that you could have solved. Now, which is faster? Is it faster to try to go direct to Mars and solve those problems right up front? That'll be very intractable in many ways. Or is it faster to go to the moon and learn how to operate there, knowing that you might get caught in that whole lunar program for some decades, and then go to Mars with the lessons you've learned? That's debatable. But I think the path we're on is the moon first, and Mars later. And how much later? My crystal ball is cloudy, but it won't be just a couple of years. It'll probably be a couple of decades. So I see all these very optimistic studies on, humans to Mars, and I wish them well, but I'm not buying a ticket yet. So
I agree with you. I think from the scientific perspective, I believe that we have to have a revolutionary advances in technology and not evolutionary. And that's the difference between them, and how between the life support, protection, and then for humans, and then also the whole transition, the length of how you can achieve the transfer to Mars and back. It's we don't have at the moment, with the difference of the Starship, which is not flyable yet. It's not operational yet. But otherwise, we don't have any kind of a launching possibility to sustain human life for that long in space and bring them back. From the logistics perspective, not even looking at anything else, just the logistics. Martin, do you have a question, or do you have a comment?
Yeah, it seems to me, I like to think back to the exploration and opening up of the New World in the 15, 16, 1700s. And that was made possible because there was a vibrant maritime economy in Europe that developed the technology for the ships and provided the trained crews, and mostly important, provided the wealth so that you could spend a little bit of money on exploration. And the most important reason I see for going to the moon first is to develop a cislunar economy that generates some wealth that becomes more self-funding. And then you can spend a little bit to explore Mars. But to do what Bob Zubrin says and go straight to Mars, well, then that's just a tax on, the Earth. And it's clearly not sustainable. You might go there, 2 or 3 trips, but you're not going to generate wealth that'll make it self-funding. So that's what I think about it. I think it's real important to, learn how to do in-space manufacturing, learn how to find something on the moon that's valuable, whatever that is, generate space solar power or something. But something that actually generates real revenue and makes an economic domain that can, where you can spend a little bit of that money going on an exploration.
You're here.
Yeah.
We have to be a little careful with historical analogies, but I think, you make some really good points. There are differences, but I think your main point is exactly on target. So good.
Well, just to make the fair discussion, Martin, even though your analogy is great, but it could be applied in both ways, in supporting direct to Mars and supporting to lunar surface. The one thing that the historic analogy did not have the issue to deal with is that protecting human from the environmental, per se, the issues that there's no need to generate oxygen. The oxygen is still there on within our on the ground, right? Within
well, think of it this way: if Queen Isabella had to use her exploration budget to develop the ships and the sailing technology and the navigation to do the exploration, it would never happen. It was fishing and naval warfare and transportation that developed the technology, and then they used it to do the exploration. In this case, we've from Mercury on, we've been developing the means of doing space travel as a part of an exploration budget. And now we do have a very robust space economy with communication satellites that are making billions of dollars for people, So we're beyond just being, trying to figure out how to do exploration. But it's got to be something like that going forward. It can't be just trying to come up with an exploration budget to fund everything.
Okay, Mike has a question. Mike.
Yes. First of all, a very good talk, Wayne. Thank you very much. And I agree with Martin that it's the commercial avenues that pushes human expansion and exploration, and that's very strong. You can't deny that. However, there's one a factor that I think is overlooked here, and that is when Kennedy announced the program to go to the moon. Everybody thought, well, okay, we'll beat the Russians, and the Americans are excited, and they do very great in competition. But what came out of the moon program, the Apollo program, the most important thing to me was national pride. And after we achieved going to the moon and bringing the astronauts back safely, and at that time we had a very good successful mission, and then follow-on missions. We developed that produced a national pride, which nobody really thought of until it happened. And that national pride seeped into all other avenues of science, art, all the society avenues. And I think that made a greater impact, a subtle impact, but a greater impact than almost anything else. And I think that national pride has lasted for a long time. And I believe it's kind of faded away a lot. And to me, the Mars program is something to reestablish that national pride. And that if we Americans and the free world, so to speak, were to land astronauts on Mars and have a successful program there in some way, mostly scientific at first, but that would reestablish a degree of national pride that would go a long way. And I believe the Chinese have recognized, the Chinese government has recognized this, and they are going after that national pride for their people. So they want to use Mars as a national pride launching pad for their people and their society for years to come. And that's nice, and I think that's great, and maybe we should help them. But that's a national pride maybe for the human race. But I think that national pride is something that can evolve into all kinds of economic factors that will advance economies all over. I agree with Martin that if we could establish some kind of a economical advantage in going to the moon early and then use those economies to further advance research and exploration of the moon and further commercial advantages, and then use that all to go to Mars, that would be great. But I think the national pride in going to Mars is very high and should be recognized. I don't think the government recognizes that much, and I think it should be recognized more. But going to the moon, the important thing to me is using the moon to establish technologies and procedures to going to a place like the moon and establishing a base, a scientific base at first, but a base of exploration. And you need that to go to Mars. And so going to the moon will help us grow up into those kind of technologies and procedures to do a Mars program successfully. And that's the main thing to me for going to the moon. But it would certainly be nice to find those commercial avenues. And I'm afraid if we just leave our basis on that alone, we'll never get to Mars, because I don't see a commercial avenue right now, like communications and geo orbit and everything. So if there's a commercial avenue for utilizing the moon, boy, I think that would be great. Those are my comments. Thank you.
Another term for your national pride that I like is soft power. And, clearly the Apollo, proved that our free economy and, democracy and was superior to the Soviet approach. Well, now, some of that's died away after 50 years, and some people are questioning whether democracy works and authoritarianism, however you pronounce it, is on the rise. So certainly having the soft power of showing that our approach works is very valuable.
Yeah, I agree.
Okay, there's Dan's question. Go ahead.
Hey, one of the things that I remember about Apollo, which is when I started out with NASA in the space program, pre-Apollo 1, the worldwide support that we had for the program. I so remember the Apollo 11 landing on the moon, and the local networks and the national networks and the international networks had pictures of millions of people tuned into their TV, to their radio, listening and watching. One of the things that seems grossly inadequate at this point with Artemis is the lack of public information, public awareness of what the program is about. I think NASA really needs to focus on keeping the public informed of, not the technicalities, not the intricate technicalities of the moon and the mission and the orbits, etc., but just the progress that's being made, the fundamental goals of the program, how it relates to humanity, how it relates to economics, how it relates to the men and women on the street. If we don't have full public support for Artemis going forward, given all the political and economic and planetary concern that are out there, I just don't see us being able to provide the support to continue the sustainability of the budget, whether it's NASA, whether it's commercial, or whether it's a combination of both. And Wayne, I'd be interested in your opinion of, you're very closely, intricately involved with NASA and its programs and its advertisement, so to speak. Is there a way we can stimulate better communication between NASA and the public on this program to get their interest, to get their excitement?
Well, they're trying. I mean, they've got a whole cadre of folks that are, into interfacing with the public, and I think they are at least at JSC right now, they're really banking on using the crew. You know, I was talking to Reed Weissman, it's the commander for Artemis 2, and they're getting pulled into a lot of public engagement things. But I mean, that's just one aspect. So they're doing a lot. In the meantime, I encourage everybody on the video to write your congressman, because that's the number one way I know to keep the program going, is if they keep getting letters or other communication that are in favor of Artemis and the funding. Right now, in the NASA budget that was just proposed, thank you very much, Office of Management and Budget, they've kind of held Artemis without much of an increase, and it needs it. And then other parts of NASA have really suffered the space science. So they need to, you know, it all comes from money, right? No bucks Rogers, as we've all heard. So write your congressman.
Yeah, no public support, no money.
Yeah, Dan, I wanted to a little kind of a piggyback on what Wayne mentioned. And with your concern, I agree that we do need to have public support. In your opinion, what do you see that in what ways the communication needs to be increased? Because what I see, and it's also depends on how well connected into whether you're following certain channels on the social media and seeing certain prints and publications and so on. But I do not see others how they may or may not see that. So in your opinion, where should it be publicized, advertised, and engaged?
You know, NASA needs to engage the public and convince the public at the middle class level. What is the return benefit to putting money in space exploration, and in particular going back to the moon? How will it benefit their family? Get that message out there. Come up with very specific examples of how a continued engagement of NASA and the commercial sector in going to the moon will benefit the public, whether it's what we learn technically, whether it's what we are able to produce on the moon and return to Earth. It just needs to be a public awareness of how it benefits them.
Well, I think what we
At
need to do
family
is,
level.
what I think we need to do is we need to get some very articulate people like Dan Bland to stand up in front of, you know, the Rotary Club and other places and tell them the story. So, you know, it's not just, we got to say, okay, the NASA Public Affairs Office take care of it.
Okay.
All of us that believe that this is important need to do our part. So,
Yeah,
I noticed the average age of participants in today's Zoom is probably just approximately the age of the moon. So we need to get a lot of young people involved.
Well, to be fair, we do have a high school student here as well.
All right.
so I gotta say, I've been impressed and going to the AIAA Houston section social events at the young number of young engineers that are involved. So I think that's
Wonderful.
Yeah.
Doing great work there.
And I want to invite each and every one of you, when you are in Houston, and it is coinciding with our 4th Thursday, we have a social in either at Nobis or Hyde Park. So you just come at 5 o'clock. One of those two places are very close. They're adjacent to each other. And if you don't find us on one, you can find us in the other. And there's always some sort of a mannequin or what as indicating where the AIAA Houston section located on that day. So Dan, I don't think I've met you in the real life, but I'm looking forward to seeing you, meeting you, and engaging with you, interacting about the exploration in general, but also the communication with the public, because I do believe it is important. I'm not dismissing your comment is extremely important, and it is important how we communicate to public and explain. I'm an engineer, and with the full disclosure, I am involved in Artemis in Gateway. So I do know the program intricacies from the inside, but it is that what is from the outside, visible or not visible, is important. You're absolutely right. I have a couple questions for the discussion, and you may be able to, Wayne, answer that. So do you think crewed asteroid missions justify the cost? And if yes, where do you see them fit in the lunar to Mars transition architecture?
You know, the agency looked very hard at missions to asteroids in about the 2011 kind of time frame. And that's harder to get to than you might imagine. I mean, it really is. What do we call those? Asteroid redirect?
Capture?
Yeah,
Redirect, yeah.
Anyway, so your question is really an economic question. Is it justified? And I know there are people that want to mine asteroids that they think they're resources. But to me, the transportation cost has got to come way down to make that economically feasible. Perhaps if one of these new rockets becomes, an order of magnitude cheaper than any other launch vehicle, then maybe we could talk. But that's kind of a, business discussion, right? Is it economically justified? If what's the metal asteroid that they're getting ready, if it were solid platinum, and you could just, chip rocks off the top of it and bring them back, given today's transportation costs, I don't think that would provide return on investment, as the business majors like to say. So while I think that certainly someday that'll be, on the table, the transportation costs have got to come way down.
I think that asteroid's name is Psyche.
Psyche, thank you. Thank you.
Also, going to the moon, if we discover there's water in the South Pole, that's a great discovery. And of course, the reason is that's great is because with water, you can do so many things on the moon. But is it really the answer to Martin's question of the economy and what are the economic avenues that will justify going to the moon and allow the program to grow? And so water discovery is good for the in situ activity on the moon, but would that be enough to spur some kind of additional commercial avenues that would justify expending the money to go to the moon? And you can bring back a bottle of water to the Earth and say, see, we can get water from the moon and bring it back to the Earth. The Earth needs water. And I don't think that would go very far.
No, I think that the real benefit is in providing a resource that's already up there. So if you think about getting, rocket propellant out of the gravity well of the Earth to go to Mars, if you could get rocket propellant just off the gravity well of the moon, which is much easier, then you have enabled Mars exploration a lot. But let's not lose sight of the fact that water extraction is going to be extremely difficult. If you're talking about permanently shadowed craters in the south pole of the moon, temperatures down there are on the order of 40 to 50 degrees Kelvin. And your spacesuit, your astronaut's not going to walk down there with a hammer and chisel to get that stuff. The spacesuit materials won't handle that kind of temperature. Very little will. And it's very likely that those water-bearing regolith areas may be harder than granite in terms of, trying to extract things out of them. So even if we do find water there, and I feel fairly confident we will, the question of extraction and making it useful, that's not going to be another technical problem that's going to be overcome. So don't think you're just going to walk down there and put your garden hose in the puddle of water and suck it out. It's going to be a little bit harder than that.
Right, and I think the economic avenues that Martin is referring to has got to be something detached from the space program. In other words, I don't think the public would get all excited because we found new ways of doing more space exploration in space by getting some materials out of the moon or anyplace else. They want some economic advantages to the Earth, to people on the Earth, from going into space and doing space exploration.
So,
And
so that's the
what-
real thing, is to have people there, and the value of these resources there. You're not bringing them back to the Earth. I read about people that want to bring helium-3 back because it would be useful in fusion energy, and I think that's a great idea if somebody could really make fusion work. I mean, I know people out at Lawrence Livermore have been trying for 40 years to get, sustainable fusion going, and that's maybe harder than going to Mars. But if they did get it going and helium-3 was important for that, then maybe that would be valuable. But most of the economic value is not in bringing things back from the moon to the Earth, but in using them at the moon or in space to go farther.
Yeah, exactly. The fusion power plant should be in cislunar space and beam the energy to the moon, to systems in cislunar space, and to the Earth. The biggest problem with electrical energy is distribution on Earth. 50% of the energy we generate goes to the ground because it's not needed at night or on a warm day. If you could beam the energy to where it's needed based on the day, night, day of the week, weather, it would be that would be a huge benefit. That would be similar to communication satellites, where it's providing a real benefit on a daily basis. And you might not want your fusion power plants on the Earth, but who knows? One thing I'd like to say about water, there's too much of an emphasis on the water. I mean, it's important, clearly, for all the reasons you said, but water is a means to an end. It's not the end value itself. It might be the means to go to Mars, and you could debate that. It might be the means to do more in situ resource utilization on the moon, but it's not intrinsically valuable. Well, it is, but not to a great degree. We got plenty of water on Earth.
And importantly, the technologies that we need to go to the moon is super important, but to the public, it perhaps is the Earth applications of those technologies that's really important. So I think one of the primary benefits of exploration, of going back to the moon, sustaining humans on the moon, are the applications that we're able to extrapolate from that process for use by people on Earth. And that's where their excitement could come in big time.
One of Zubrin's books, he did a calculation on the value of having rocket propellant on the moon at its gravity well compared to bringing it up from Earth. And it wasn't very attractive, but I have not gone back and tried to duplicate his calculations. I don't know if anybody here has, but I think I will. I'm going to go do that soon.
Okay, I have a couple questions on both kind of a legacy and lessons learned, and then the personal reflection and advice area. One is from your experience, Wayne, on the space shuttle, what the lessons from the Space Shuttle Program do you think would be most influential in the shaping the strategies and technologies for Artemis?
Well, that's really interesting. So the space shuttle became a great platform to do in-space assembly, repair, maintenance, if you will. And I think the lessons that we learned operationally to assemble structures, to service or repair satellites. I think those lessons are going to be vital as we go further into space. I'm thinking about, other things. We learned really a lot about hypersonic flight through an atmosphere, which is going to be important, not just every time somebody wants to come back to Earth, but also in planetary atmospheres like Mars. I think there are a lot of lessons, and I think probably there's a subtle lesson in there. Maybe how we didn't do things is the space shuttle was the first reusable space vehicle, right? And it wasn't 100% reusable. We always, threw away the big tank, but we found out that reusability came with cost. I mean, the turnaround was extraordinarily expensive and difficult. And so looking to the future, when people design reusable space vehicles, they've got to take that into account. I really think the designers of the Space Shuttle, and I had long talks with Bob Thompson, who was the original Space Shuttle Program manager from ATP through the first flight. They had to focus on making the thing work, just doing what it needed to do, and reusability was kind of a secondary. I mean, it was a goal, but perhaps I should say it this way: making it easy to maintain and reuse was a secondary thing, and as a result, it took longer, it cost more to turn the vehicle around than you really needed. I mean, if you go back, they thought the shuttle was going to fly every 2 weeks, right? We're going to fly 26 missions. I think some earlier studies have been more than that a year, but 26 missions a year just boggles my mind. Now SpaceX and their Falcon 9 is well ahead of that, right? They're reusing boosters and flying much more frequently than that. So apparently they've learned some of the lessons. And I think that may be part of the legacy of the space shuttle is as you build new vehicles, you've got to consider the reusability, the turnaround logistics.
Thank you. Great answer. Okay, and 2 more follow-up questions, but they're more from the personal reflection. Reflecting on your extensive experience, what has surprised you most about the evolution of space exploration strategies over the years?
So people have been, folks were studying on how to go to the moon and Mars before there was a NASA, right? And in the 30 plus years that I worked in the agency, there's always the advanced program guys, coming up with new ways to go to the moon or Mars, and so folks have been studying on this for many decades, and I got to tell you, the technologies or the innovative plans haven't really. I mean, as great as they are, they're not really that surprising. What's surprising to me is how hard it is to get an agreement on a plan and get approval to execute it. Okay, that to me is the most surprising thing. When I came to work at NASA before first shuttle flight, I thought, hey, we will do this shuttle thing for a couple of years, and then we'll build the space station, which was envisioned to be more of an in-space assembly place, and then we'll go back to the moon and on to Mars, and I'll be in my dotage, I'll be looking at how many missions we flew to Mars, and clearly none of that happened. Right? I mean, we did the space station for 30 years, and we finally put together a space station after a decade worth of work, and then everything just takes so much longer. So I really wish things would evolve faster. And the plans that are made, there's any number of different studies that have looked at using this launch vehicle, that launch vehicle, some hypothetical launch vehicle in the future, spacecraft of all kinds, and they're great, and you learn a lot from them. But the real problem is getting agreement on a plan and execution.
True. Okay, before asking my last question, I have to read. I overlooked a couple questions that were asked earlier in our discussion. So one was from Dan, and I thought Dan would ask his own question. Given the technical and programmatic, budgetary, political challenges, what do you think is a realistic 20 TBD expectation for the first Artemis mission to land on the moon? And I guess the key word on realistic.
So I'll answer it this way. During the shuttle program, we always looked at the launch schedules, and the number one thing we did was, when we were working a mission like I did, was you always put your family vacation on the launch date, because it was guaranteed to slip. If you put it in between the missions, you were more likely that the mission would slip into it. So I have no crystal ball on launch dates. It's hard. I would expect slips, whether it's going to be a month, a year, 2 years. That's too hard for my crystal ball to say. I wish him well. I hope it happens on the schedule that they've got out there, but I'm not buying my plane ticket to Florida to watch it yet. So.
Okay, well, I'll reach out and see when you buy a plane ticket, so then I'll join you there.
Okay.
And second question from, I hope I'm not butchering the name, Gasper Verant. When do you think private launch vehicles will entirely replace SLS for trips to the moon? And when do you think the moon base will become self-funding?
Oh my goodness. So yeah, okay. So per the last discussion, the when may be the hardest part, right?
Well, the kind of it's not when the exact date.
Yeah.
It's maybe a decade, or what projections?
So I'll tell you the when that the commercial launch vehicles will replace the SLS is when they demonstrate the reliability and reduced cost to an adequate degree. So that's not going to be the first time they fly or the 10th time they fly. But if I were in the SLS program, I would be looking very hard at how to reduce the cost of that rocket. It's an extraordinarily capable rocket, and the reliability, demonstrated reliability, is extraordinarily high. But the cost is not where it needs to be, like the space shuttle. So they need to work on maintaining that reliability and safety, but at the same time reduce costs and fly more frequently. If they do that adequately, the new commercial launch vehicles may never replace it. So it's a little bit of a technology and financial challenge. And let me tell you, having been as a program manager, the money issues were always harder than the technical issues.
So true. So true. Thank you, Wayne.
So do I get a last word before we get off the stage here? Because I feel like
yes, you will. I will ask one more question. This is the last question, I promise. And then you have a last word. If you are not, if it's not the answer to this question, you never know.
Yeah.
What advice would you give to young engineers and scientists who aspire to contribute to projects like Artemis?
So I would say, first of all, you have to do your job very, very well. You have to really focus on what it is that they're trying to accomplish, what the goal of your design, your operation, whatever it is, what it is, and make sure that you give it your full attention and your full capability, because space is very unforgiving, and any shortcoming will show up. We can't, I don't want to say failure is not an option, because I think failure can happen, but what we want to do is work so very hard that it's very rare, and and put off for as long as possible. So if you want to succeed in your career, if you want to succeed in the terms of the program carrying on for many years, do your job to the best of your ability. As Gus Grissom used to tell everybody, do good work. And that's the best advice I can give.
Thank you.
Well,
Thank you. Great advice.
so my
And
last
now-
word of advice
yes.
for today,
Absolutely.
because I see the clock is ticking toward time to close, is for all of you that remember, I advise you not to stir your cryo tanks today. Those that get it will get it. Okay, it's an anniversary.
Okay. Well, thank you so much. And again, yesterday was the another anniversary of the first human space flight. Yuri Gagarin left Earth on April 12th, 1961. And so that was yesterday, many years ago. And we're looking forward to many other human space flights and exploring the universe. Thank you everyone for joining us. I am looking forward to next Saturday when we will have yet another discussion about out of this world issues and challenges. Have a great week. Thank you, Wayne.